Hello, Algebra 1. Welcome to 10.1. We're starting in our notebooks today. Discriminant is what we're working on today. Discriminant is something that actually has to do with our quadratic formula that we've been working with for a while. With the discriminant, all we're going to be using is the inside of my square root of b squared minus 4 times ac. This is the discriminant. Discriminant. I hope you're all settled in for this lesson. So today we're going to be talking about different types of numbers. So there's something called real numbers versus imaginary numbers. But first we're just going to be talking about real numbers and how some numbers have no real solution. There are two types of real numbers that we'll be talking about in extent today. And that is one, my rational real numbers. And then my second is my irrational real numbers. My irrational real numbers. So my rational numbers is anything that could be a fraction. So any fraction is a rational number. Think a whole number, 7. 7 is a rational number. I have 3 over 4. That's a rational number. Square root of 4 gives me a 2. It's rewritten in a different way, but it still gives me a rational number, a whole number, which is 2. I can have a repeated decimal, like 0.33 repeated, like it goes on forever in a calculator. And this is the same thing as 1/3. It is a rational number because it can be turned into a fraction. Anything with a decimal that stops. So for example, another way, so this is a repeated decimal. It does go on forever, but it turns into a fraction. Also rational number is 1.34 because it does not continue forever. Irrational numbers do continue forever. They are our scary long decimals. Scary long decimals. They go on forever and ever and ever. Think the square root of 2. Can we take the square root of 2 in your head right now? Is that a perfect square? No. If I take my calculator right now, if I take the square root of 2, I get this really long number. I get 1.414213, blah, 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 blah. It goes on forever. Or it just goes on in a way that is not predictable. More so. Another irrational number is pi. Pi is irrational. It's 3.14 and it goes on forever and ever and ever. So these are my irrationals that we're going to be talking about. So once again, something important here is that the square root of 2 is not perfect square. We've been talking about what perfect squares are in my class. The square root of 4, perfect square. Square root of 9, perfect square. So again, we care about this. We care about this being a perfect square. That's what makes this question rational versus irrational. Perfect square. Think the square root of 9, think the square root of 16, so on and so forth. So these are the two types of two types of real numbers that we'll be working with. Rational real numbers and irrational real numbers. Our discriminant, and let's talk about this, our discriminant is again our b squared minus 4ac. I want to talk about where that is in my quadratic formula. In my quadratic formula, this b squared minus 4ac is inside of a what? Talk to your partners. What is that inside of in my quadratic formula? If you said it's inside of a square root, you're right. This, in my quadratic formula, QF, and I'm writing it in a different color for a reason, because it's not part of the discriminant. The discriminant is without the quadratic, without the square root. But it's important to understand what's happening here. Inside my square root, we can get a positive number, we can get a perfect square, we can get a non-perfect square, and we can also get a fourth choice, a negative number. Has anyone ever taken the square root of a negative before? For example, here is a square root of -7. Error, not non-real answer. Non-real answer. In Algebra 2, we will talk about how this becomes imaginary numbers, and imaginary numbers actually explain electricity, and it's super interesting. But in Algebra 1, we just call it a non-real number. It's an error. It doesn't give me an answer. So if I take the square root of a negative, it gives me none. It gives me an undefined. It gives me a no. A positive in there gives me a happy answer. Very lucky duck. So here's what we're going to be talking about. Our discriminant is going to be telling us how many answers we have and what kind of answers we have. So as we know, when we've been taking the quadratic formula in my class so far, we've been getting 2 answers every single time, which is great. We're going to talk about the 3 or 4 types of answers we can get. So first of all, if I plug in my numbers from my quadratic formula into this b squared minus 4ac, again, no square root on it, I'm getting the discriminant, and that will, again, just tell us what's going on. So the discriminant tells us the quantity, I didn't spell that right, quantity, let's redo it, quantity, the quantity of our answers, quantity of, and we don't say answers in my class anymore, we say solutions. The quantity of our solutions. Again, we've been working with 2 solutions all this time. I'm also going to introduce 3 more words for the word solution. Solutions, aka roots, zeros, and x-intercepts. Next class, we will be graphing quadratics, and this will make a lot of sense as to why they're called x-intercepts, why they're called zeros, why they're called roots, once we look at the graph themselves. But it's important to me that we know these other names for solutions. It might be an extra credit question I ask the class, or it might even be a way you can get a homework pass from me next class. So please remember the 3 other names for the word solutions. This is, again, the answers to our question. So the discriminant, and we're going to be using the letter D for discriminant. D is equal to my b squared minus 4ac. Again, it just tells me how many I have for my question and how many of what type of solutions I have. Okay. So if D is greater than 0, what kind of question is that? Is that positive, negative? Is it none of the above? If D is bigger than 0, then it is a positive answer. So if I plug in my question, so we will do an example together in a bit. Right now we're just making a chart. If what I get from this spot right here is positive, I can get one of 2 things. And I'm trying to make sure that we can see. Woohoo. Miss Ryan from home. This is her in action. Okay, cool. So if it's positive, we can do one of 2 things. It could either be 2 real, rational roots. Again, solutions, zeros, x-intercepts, all of these are the same words. 2 real rational roots, box that. That's one option. If the number that we get is a perfect square. if perfect square. So think of an example like the square root of 9, the square root of 64, aka all of these things that we can take the square root of and get no decimal from if we plug it into our calculator. Again, this is a no decimal rational, which is what we just talked about. And then the second option is if I get a positive answer for my discriminant, is 2 real, what's the opposite of rational? Irrational roots. Meaning that I get a positive question. Should I get a square root for my discriminant, by the way? I just wanted to bring that up. No, I should not. I just want to bring that up before I confuse anybody. I don't need to see the square root. I'm just letting you know that's how perfect squares work. You can put other examples here if you'd like. We could do 81. It's just something. Again, I don't want to see square roots for a discriminant. It is just the b squared minus 4ac's answer. Okay. Irrational roots means not perfect square. Think 17. 17 is not a perfect square. If d is equal to that. If d is equal to 19. If d is equal to 127. All of these things are non-perfect squares. If you plug this into your calculator with a square root on top of it, you will not get a whole number. You'll get a decimal. Okay. Now, what happens if d is equal to 0? My discriminant is equal to 0. Can we see that well? Is that okay? Okay. I feel like I need to move this. Give me a moment. Okay, I hope that's better. If d is equal to 0, that means, again, I get a 0 for my answer. Instead of a positive number, instead of a negative number, which we'll go over in a second, I got a 0 for my answer. If that happens, I only get one real rational root. Only one real rational root. Because I can't split this up into a plus and minus. I could never do that. It just says 0. And then last but not least, if d is less than 0. And catch up with me, I'm going to give us a second to do that. And you can always pause if you need more time. Okay. If d is less than 0, that must mean I'm working with a negative number. And this is probably a good time for us to highlight this. If it's positive, if it's 0, or if it's negative, and then d is equal to that thing. If it's negative, like our calculator said, when we did this, we got an error. On your calculator, you might see something different, but on mine, it says non-real answer. We're going to write no real solution or root, whatever you would like to use here, as long as it's one of the words that we have worked with. Okay. So now you have this chart ready for us to go. I would like us to all grab our homework now. I'm going to give, well, you guys can pause me now and have your homework in front of you whenever you're ready. If you would like to volunteer to give up the homework, that would be really nice of you for the sub. Thank you. All right, ladies and gentlemen, I very kindly did number 1 for you, and now I'm going to very kindly do number 2 with you. So let's go over number 1, what happened here. Here I gave us a quadratic equation. My equation that I gave us was x squared plus x is equal to negative 2. My question to you is that in standard form? Is that the way that we want it to be for it to be a quadratic formula activity? And here, again, we're not going to do the whole quadratic formula. We're just going to find the discriminant. Is this equal to 0 like I want it to be? No, it isn't. I need to move this minus 2 by adding 2 on both sides. I get x squared plus x plus 2 is equal to 0. From there, you're going to label my a, b, and c values. So I have a is equal to 1, b is equal to 1, and c is equal to 2 here. Again, if you can't see that, write it in so you can see it. We're going to plug it into my discriminant formula. I got b squared minus 4ac. I got 1 squared minus 4 times 1 times 2. And I get a negative answer here. And you're going to check your chart. With a negative answer, is that happy? Am I happy with that? No, I get a no real root. I get no real roots, again, because it's a negative number. Now let's do the second one together. Is this in the notation we want it to be, where it's equal to 0? No, I have my minus 1 on the side. We're going to add 1 on both sides. I put it over here for a reason, because my minus 1 is my c value. I want it to go right at the end here. So I get x squared minus 2x plus 1 is equal to 0. I'm going to label my a, b, and my c. A is 1. It's right in front of my x squared. B is negative 2. Please do not lose my negative there. And c is a positive 1. Now, please be careful as it started as a minus 1. We should make sure that we are adding 1 on both sides because it's the opposite. Now we're plugging it into our discriminant. I have b squared, so negative 2 squared, minus 4 times my a, which is 1, times my c, which is 1. Negative 2 squared, negative squared is a positive, so I get 4. Minus 4 times 1 is 4. 4 minus 4 equals 0. Check your chart. How many roots do I have, and what kind of roots do I have? It's equal to 0, which means I only have one real rational root. Please make sure you are writing the word rational or irrational with your answers. I only have one real rational root. I hope this makes sense for you. The back is the same thing, just written in a chart formation. Again, I did a couple for you. I did one on the top, one on the bottom for you. You are just answering which kind it is. You are not going to put an X on the ones that are not correct. It'll be cleaner. It'll be easier for me to see what is right and what is wrong on your paper. Okay, if you have any questions, please talk to me. Please talk to the people around you. You guys are very smart individuals. And if you need anything, you can always send me an email. If you have any questions, comments, or concerns, let me know. I'll be back on Wednesday, and I hope you are being kind to the sub. They deserve your kindness, just like every human deserves some kindness. Okay, I hope you're well. I miss you all, and I'll see you on Wednesday. Bye.